Okay, morning everybody. So today we're moving on to the very next section. It's not that complicated conceptually. We're just going to talk about a specific base for a log. There's two bases that actually are useful in the real world. Logs with a base of 5 or logs with a base of 8 are cute and all, and they might help solve you some problems with a base of 8 or something like that. But there's much more natural things to use. There's two logs. One's called a common log. And that was what we're going to talk about today. That's base 10. The only reason that's special is because the humans all made their number system around the number 10, because we got 10 fingers. So that's what we're going to talk about today, logs with a base of 10 specifically. The other one, which is far more useful mathematically, is something with a base of e, called a natural log, which is what we'll talk about on Friday. So the next couple lessons are just about specific bases using only logs with a base of 10 or only logs with a base of e. So that's what we're going to talk about starting the rest of the week. Now, the warm-up today is just asking you, do you know how to not mess up your properties? Okay, so those three properties of logs that we've been talking about, what do we got? Three of them, product property. One of them says, if things are multiplied together in a log, so these are both inside the log, right? Then you can break it up into the two logs added together with them kind of separate like that. And you can always go backwards too if you wanted, right? If you had a log plus a log and they had the same base, you could always put them back together into this. The other property, there's a quotient property. If you have x divided by y, well, you can do log of the top one minus the log of the bottom one. And the third property, which is what we're really going to hit a lot today, is if you have a log with a base other than the base of your exponential, well, these don't cancel out, but your exponent does in fact come out in front. So these are the big three you really got to have under your belt to get through the rest of this unit here. And the warm-up today is just checking that you don't jack them up. Kids very commonly will mix up which identities you can do what. They might think there's a identity. Do you see an identity with the addition inside of a log? Do you see? I don't see that either, but a lot of kids think if you have something x plus y in a log, you can break it up or something like that. But make sure you know which rules work when, and that's kind of the point of the warm-up today. Do these actually work? So number one, they give you an equation where they have log of something minus something in the log, right? Do you have any property for subtraction in a log? No, you do not. So can you just say it's log of one minus log of the other? The answer is no. Write down no. That's a bunch of nonsense. That's your answer for number one. Write down the problem and say that's not true. That's not going to work. It's terrible. Number one was log base 8 of this thing. You cannot split that subtraction up like that. Now, number two, if you look at that inside of the log, you have division. Can you break that up? Yes, you can. That is the quotient property right there. You have log of, say, x divided by 3. Yes, you can call that log of x minus log of 3. So 2 is okay. That is the quotient property. You agree? That is that thing right there. Now, number 3, if you look at that, inside that log, they have two things multiplied together. So by the product property, if you have two things multiplied together, the only way you can break it up is the log of one of them plus the log of the other, which is not what they have, is it? They don't have log of 19 plus log of k, do they? That's not going to fly. So no, you can't just put the 19 in front like that. That's not how it works. There's no law about that. So 3 is also a bunch of nonsense right there. But equation 4 is not. If you look at equation 4, that is a product also, 22 times x, but they broke it up in the right way this time. If you have a product, you can break it up in the log of one plus the log of the other. So you got to be really careful about not making dumb mistakes, okay? Just because you see log, like number one, if you see log of x minus 3, don't assume that you can do log of x minus log of 3. That's not a property. That's the number one thing I see go wrong on tests is kids will just kind of make up their own rules about the logs and not be clear on what they can and can't do. So be very careful that you have these 3 down very, very well. That's pretty much it. Any questions over the warm-up? Anything at all? That was an easy one, right? Didn't really do any work, just kind of thought things through, but that is important. So there we go on that. All right, let's do some LGs, and then we'll get ourselves to work today. Here we go. Oh, yeah. Solve exponential equations. But we're going to do it specifically using something called a common log. It's nothing special, okay? Please don't think anything the rest of this week is anything new. We're just doing logs with a very specific base. That's it. In fact, this is good for you. Also, later in the lesson, we'll talk about how to change the base. It is possible if you have a log with a base of 4, if you wanted to turn it into a log in terms of logs with bases of 5, or you want to turn into logs with the bases of 8, you could do that. There's something called a change of base formula, which once in a while, if you do have a weird log, like a log with a base of 4 or 5 or some number that's not 10 or e, then you might actually want to consider doing that and changing it over. Honestly, everything in this unit so far, we're using log base 6 and log base 8. That's cute and all, but I want to try to get you away from that now. I want you to start getting the habit of only using one log to solve a problem. It doesn't matter what the base is. Today, we're going to specifically talk about a base of 10, but that's your job. Get comfortable with using just one log to solve any exponential problem. 8.2 is due today. And of course, you got the new one here, 8.3. That is going to be due on the normal thing, Friday, 2 days. Got tomorrow to work on it. It's not going to be tricky conceptually. The main thing that's going to throw you off is not freaking out when you see a log written somewhere. And just like with any other number, if I write this pi symbol, everybody freaks out and they don't know what to do with algebra anymore. Well, if I write log of 8, don't freak out. That's just a number. So we're going to do the same thing we always do with numbers. It's just going to look a little weirder. And historically, kids usually have trouble with that. That's it. 8.3 due on Friday. Let's get started. All right, notes. 8.3 today. The topic is common logs. Common logs. This one is not insanely important, other than the point that humans use this one a lot. So here's what a common log is. It's that button on your calculator down on the very bottom left. You see on the left, there's those log buttons. You might want to get your calculator out today because we're going to have to explore that just a tad. Down the bottom left of your calculator, there's a button that just says log. That's it. Most of you probably going into math so far, right? Going down to log base and all that stuff, you know, and that's fine. But today, we're going to concentrate on those two buttons, log and natural log. Log today and natural log on Friday. But a common log, it just means a log with a base of 10. Okay? So when somebody writes the word log without a base, automatically that's implied that the base is 10. That's it. Okay? That's all there is to it. So make sure you understand that the word log alone means log base 10. And again, this is nothing special. It's just that humans built the entire number system around base 10. You know, you got 10 ones to make a 10, you got 10 tens to make 100, you got 10 hundreds to make 1,000. That's how our whole number system is based off of. If you're doing like computer stuff and you were doing binary stuff with bases of 2, maybe you'd want to use log base 2 all the time in your world and stuff like that. But since everything here is log base 10 or basis 10 for things, we're going to common logs have a lot. They come a lot in Richter scales. That's what a Richter scale is, a log scale base 10. pH levels in chemicals is log base 10 kind of stuff. Amplitudes and frequencies and things like that of electrical signals are all common log things. So we use them a lot because we use the numbers 10 in our stuff. That's all it means right there. Let's practice just using this button real quick to make sure we can, you know, type things in a calculator. Go to your calculator real quick and just hit the log button. Let's just see if we can find log of 8. It's not anything different than what you've been doing. Hit the log button, hit the number 8, and if it opened a parenthesis, close the parenthesis, hit enter, and make sure you can get this decimal that's on the board right here, so you can just type things in. Should look exactly like it does on the bottom there. It just says log, right? You got to know now that log means log base 10, right? So this is secretly you're saying log base 10 of 8 is this particular number right here, and that's really all there is to it. Okay, that's it. What's going to be tricky today is that I'm going to start expecting you, and the book is going to expect you in this particular section to solve things only using logs with a base of 10. So write down this problem real quick, and this is where it's going to get a little bit hairy. It's going to be a little bit weird for you at first. 11 to the x is 101. Notice that there's no tens involved anywhere. Would you concur? That base is 11. That's 101. 10 doesn't go into that. So you might think, well, up to now, you do what? Log base 11? Yeah, and I wouldn't blame you for that because that's what I've been training you to do the whole time, and the curriculum has done as well. However, today you only are allowed to use log base 10, common log, okay? So what do you do? Well, this is exponential, okay? So you use a log, but I'm telling you, you can only use log base 10. So you do a log base 10 of this side, and you do a log base 10 of this side. Notice I'm not writing the 10 below because it's implied when I just write the word log, it means log base 10. And you might think, well, that doesn't do me any good. because if this is base 10 and this is base 11, they don't cancel, do they? But we have that power property. Remember, even when the bases aren't the same, what can you still do with the exponent? Bring it out in front. And that's the main theme for today. So that's exactly what you're going to do. And that's why this third property, that power property, is very important. We're going to do that over and over again. So by the power property, the exponent can come out in front. I'm always going to draw a little arrow for you guys just to remind you that's what the property is. When the exponent comes out, what's left is log of just the base. Log of 11 right there. And that's nothing we haven't done already, right? So same exact junk. Only thing that's going to throw you guys off here is you're going to freak out when you see logs floating around because you're going to forget how to solve things real quick. Anybody got any thoughts about how to get x by itself here? Well, see, this is exactly what happens all the time. I'm going to rewrite this. Don't write this down. But what if I just wrote this problem? What would you do with this? You would divide by 11, right? Because this is just a number, correct? This is just a number. And kids see this and they freak out and they think, well, I don't know what to do. But you do know what to do. You know what to do if it was a normal number, right? You would divide by 11. For some reason, when I say this is the number, you don't know what to do anymore. But if you have x times this thing, how do you get rid of it? Divide by this thing. So that's exactly what you're going to have to do on these kind of things. You're going to divide both sides by that number, log of 11. And of course, like anything else, the whole point, reason you're doing that is so on the left that the log of 11 and the log of 11 cancel. So your final answer looks weirder than normal, but that's okay. We did solve for x without using anything besides a common log. So the final answer is log of 101 divided by log of 11. And a lot of your problems today are going to end up looking like weird things like that. Log of this divided by log of that, or maybe there's a 4 in there or something like that. So that's the main theme today. You're going to be solving problems without doing anything else besides using a common log. Let's try another one to warm up. Because the next example I have is pretty complicated. So let's get doing a little mini one. Let's do another one. Example 5 to the x squared is 7. Something like this. 5 to the x squared is 7. Well, same thing as always. This is exponential, right? I need a log to undo it. You're only allowed to use log base 10 today, right? That's all you're allowed to use. You use log base 5, you're doing it wrong. Don't do that. So we're going to do a log base 10, or just log, right? That's what log means, log base 10, of both sides. So I did a log of this side, I did a log of that side. And why are you doing the log? Even though these aren't the same bases, we still have our power property, and the exponent can come out in front. Can't emphasize that enough. That's the main point of these log things. So the exponent was x squared. Well, okay, x squared comes in front then. So I have x squared times, and what's left is just log of 5. And of course, that's still equal to this side of log of 7. And again, if this is tripping you up, I encourage kids all the time to do this. You know, if you get stuck ever in my class with something complicated, you don't know what to do, go off to the side, write the exact same thing, and take out the part that's scaring you. Probably the word log scares you, right? So if I write the exact same problem without the word log, I think you probably know what to do. How would you start solving this? You'd probably get rid of this 5, or would you divide by 5 first, right? Then you have x squared. How would you get rid of the square? You do a square root. Well, we're going to do the exact same thing over here. So over here, the x squared is times 5 is times log 5. So we're going to divide by log 5. Log 5 is just a number. You can do the same thing you always can. So if you divide both sides by log of 5, then on the left, it's gone. And on the right, you divide it by log of 5. So your x squared is log of 7 over log of 5. And then, of course, just because it's got weird logs in it doesn't mean, again, it's just a number. This is just a number. So if x squared is a number, how do you solve for x? You take a square root, right? Don't forget your plus or minus. So x is going to be plus or minus the square root of this thing, log 7 over log 5. There's my final answer on that. Makes sense for the most part. Would you agree? Okay. So let's see one example where it's really going to step it up a little bit. Here's an inequality one. Not that the inequality is really the scary part here, You're going to see why this is scary in a second. Go ahead and write this down. Remember, with inequalities, you do the same exact stupid thing you always do. We did this last unit with inequalities, and just because it's exponential doesn't mean you do anything different. You go solve it with logs. You're just going to get a range of numbers out. But the algebra for a problem like this is really going to be more of a pain in the butt to solve it. In fact, this is about as bad as it's going to get. So if you can understand this particular example, we'll probably practice another one after this too, just to really hit it home, then you really are pretty fluent in the gist of logs, and you should be okay on things. All right, guys, here we go. Ready? I see exponentials. I'm going to undo them with a log, right? What's the log you can use today? Just log base 10, right? So that's what I'm going to have to do. I'm going to do log base 10 of this side, or just log, in other words, which means I got to do log of that side. So I'm doing a log not because the bases are going to cancel, but because the exponents will come out, correct? All right, so that's exactly why I'm doing that. So for both sides, these exponents are going to come out. Now don't do this. This is 2y minus 5, right? When it comes out, don't write this. Anybody know what's wrong with that? Yeah, that's right. The whole exponent has to, whole exponent times this, right? So you need to put it in parentheses. That whole exponent of 2y minus 5 is times the log of 6 there. We clear on that thing? Yeah, make sure about that. And similarly, over on the right, well, it has the same effect. These aren't the same bases, but nonetheless, the exponent can come out in front. So exponents out in front, exponents out in front. So now you have 3y log 5 on this side. This is going to be painful. Now pay very close attention to these steps, okay? And we'll do another one after this to make sure we kind of get the gist or something like that. Looks confusing, doesn't it? Looks confusing to me. Well, let's go off and do a little analogy for a second. I'm going to replace all the words log with just the numbers that there was. So instead of log of 6, I'm going to just write 6. Instead of log of 5, I'm just going to write 5. Fair enough? Okay. Now, if you look at this analogy, what does your gut tell you to do with this thing? Any thoughts? Take a guess. What do you think you should do? Get y by itself. How am I going to get y by itself? I think I might distribute the 6 in. That was a good suggestion. I like that. Do you agree? Might be a little bit better. Okay. Well, if you did, what would you have? You'd have 12y, right? Minus 30, and then you'd move some other junk around, wouldn't you? Okay. Well, I like that idea. So if you would distribute this 6 in, what do you think you should do in this problem? Distribute the log of 6 in, as weird as that is. So let's distribute this log of 6 in. So over here with a 2y, I have a 2 times a log of 6. Those are just numbers, right? 2 log 6 are just numbers. And then also times y from the first distribution. And then I got a minus 5 times log of 6. And then over here, let's see, what else would you do in your analogy? Over here, I don't think you'd probably write 3y times 5, would you? It's kind of a natural. You'd probably put the 3 and the 5 together, wouldn't you? Call it 15 or something like that. So you're right. Well, over here, I can't really put these together, but I can at least write them in the right order. Maybe I'll put the log and the 3 and the log and the 5 all together, and then the y off by itself or something like that. This is just a number. It's this many y's. This many y's. This kind of thing right here. Okay, so the big note I would have to say, and you might even want to make a note to yourself, because it's always the same process on these kind of problems. At that stage, you should distribute, correct? First thing you got to know, and that just takes experience, is when you have this junk times this log, we'll distribute the log thing inside of it. Okay. Now back over to my analogy. What would you do now? I get all the y's on one side, wouldn't I? Yeah, I like that. So maybe you'd move the y's over there. It doesn't really matter, does it? Which side? I'll move the y's over here. How many y's? Well, you'd have what? 15 y's minus 12 y's then, correct? I like that. You're getting all the y's on one side. Well, what do you think we should do over here? Let's get all the y's on one side. So we're going to, again, it doesn't matter. Let's just move this one over there. Doesn't matter. Okay, so we're going to take this whole thing. This is just a number. Don't freak out about it. If you had 5y, you'd subtract 5y. If you have 8y, you'd subtract 8y. If you have 2 log 6y, you're going to subtract 2 log 6y from both sides. So if you move this over, well, then you still have this negative 5 log 6 chilling over there, correct? But on this side, you have 3 log 5 of y. But now it's minus 2 log 6 of y right there. We're getting there. We're getting there. We're almost there, actually. All right. Now, back to my analogy. Now, this is something you've done in your whole life, so I think you're pretty comfortable with this side. What's this the same as? 3y. Because you know, what do you do in your mind for a minute? You take out the y's for a minute, right? You don't worry about them. You say, I got 15 minus 12 of these things, right? What you're really doing, even though you don't know you're doing it, is you're factoring out the y temporarily. And you know that 15 minus 12 is 3, and then you call it 3y. Well, this is weirder over here, but it's actually the exact same thing. See, in your mind, you're factoring the y out, correct? Well, guess what we're going to do over here? We're going to factor the y out. So that's the other big tip for solving this. Right here, they both got a y, so I'm going to factor the y out. Doesn't matter which side I put it on. I can put it on the left or the right or something like that. And that's the other big tip to get through these problems. You have to know at that first stage we talked about to distribute out that log. And then later on, when you get all the y's on one side, you got to know to factor them out. This is the hardest kind of problem you'll ever see. So we're almost there, actually, in our analogy. What's the last thing you'd do over here if you had to do it? You'd divide by 3, wouldn't you? Well, what am I going to divide by here? What's y times? This weird thing, right? Well, I guess I'll divide by this weird thing. However, I do need to be really, really careful because with inequalities, right, if you divide by a negative, what do you got to do? You got to flip it. So I'm about to divide by this thing, right? Are you comfortable with where that's positive or negative? I'm not either. Why don't you actually take a second in your calculator and just type in this part. Type in 3 log 5 on your home screen. Remember, you can just use that log button, right? You don't have to go to math or any of that nonsense anymore. Type in 3 log 5 minus 2 log 6. And let's just see if it's positive or negative. I don't even care what it is. Some random decimal. But is it positive? What is it? 0.54. 0.54. Everybody agree? So that's positive, isn't it? Okay. But I needed to check that because if it had been negative, what would I have to do? I'd have to flip the thing. But in this case, we were okay. So if I divide by this junk, then the final answer is going to be this side, negative 5 log 6, but divided by this whole ugly thing, 3 log 5 minus 2 log 6. Wow, that sucked, didn't it? But if you can master this particular problem, or ones like it, then you really are going to be fine on any log equation I throw at you on your test. Now, of course, and to make it even worse, I don't want your answer written like this. I always want an interval notation with parentheses and brackets and that kind of crap. So can you read it backwards? Y is more than this, right? Y is bigger than this. It eats the bigger one, right? So y is bigger than this. So I'm looking for all the numbers from this, negative 5 log 6 over 3 log 5 minus 2 log 6. All that things from that number to infinity. So yes, interval notation is always the best right there. And you might get some disgusting things like this out. And that's what's going to suck about today's lesson. It's not that a common log is tricky. It's a log base 10, no big deal. It's not that the power rules are anything complicated. Yes, I can bring the exponent out in front. That's fine. It's going to be the tedious algebra to get y by itself after that and not freaking out when we see the word log of a number because it's just a number. Let's practice that again because that does suck. Yes, you may. I will try to do something simpler, though, a little bit easier, just to remember the idea. So let's try this one out. Example, making up stuff on the fly. 8 to the x is 9 to the 1 minus x. Something like this. I don't know. You can expect your problems to suck like that one when they both have x's in the exponent. Do they both have x's in the exponent? This is probably going to suck then. That's a green light to you, like, oh, this is going to be a pain in the butt. All right, today you're only allowed to use common log, so here we go. Log of this side, log of this side. So you always start off one of these problems. Just an equation this time, no inequality or anything like that. Don't have a range of things. And of course, the whole reason you're doing this is because it doesn't matter that these bases are different. The exponents can still come out in front, correct? So this first one is x times log of 8. And this one is, make sure you put that exponent in parentheses when it comes out, because all of 1 minus x times what's still chilling there with a log of 9. Any questions over the steps so far? Okay. Now, according to your last example, what would be the next step to do in this? Yes, indeed. Let's distribute in this log. As awkward as it is, it's just a number. We're going to put it into things. So over here, I have x times log of 8. And over here, if I distribute the log 9 in, log 9 times 1 is just log 9, right? And log 9 times x is just log 9 times x. There's really nothing you can do with that, right? If you had a 9 times x, it'd be 9x, right? If you had 8 times x, 8x. Well, if it's log 9 times x, it's log 9 times x. Okay. Now what? Thoughts? Well, I'm going to go back to my analogy then. I'm going to replace all the words log with just the number, okay? So first of all, is it normal to say x times a number? Or do you say a number times x usually? No, usually number times x. Doesn't matter. No, but I'm going to write it in a more familiar way. So back to my analogy, if this was 8x, and this was 9, and this was 9x, notice I just dropped the word log and everything, correct? You would know what to do in this one, wouldn't you? What would you do? You get all the x's on one side, wouldn't you? Well, that's what we're going to do over here. We're going to get all the x's on one side. And I'm going to move this one over here because, why not? So if you move this one over, it's a positive log 9 of x times x. This one, I just can't help myself but write in the correct order. You could write x times log of 8, but it's more natural to me to write a number times x, 7x. Who says x times 7? Nobody does that. So you got this. Good job. You got the x's on one side. There's one other thing you have to remember to do. You either know to do it or not. What's the last thing to do? Factor. Yep. What goes into both of these on this side? The reason you got these x's on the same side is because they both have an x. So you factor the x out. So it came out of both of them. That's the other step you got to know. And the whole reason you're doing that now is that don't freak out again. If you had x times a number, you'd know what to do. If this was 11, what would you do? You'd divide by 11, right? Well, this is no different. If it's x times this weird junk, we're going to divide by this weird junk, and we're going to be all done with it. So x is log of 9 divided by that stuff. Log of 9 plus log of 8 right there. Those are as bad as it gets. I'm kind of worried about those. I'm always worried about those. Every single year, this is a deficiency. I don't care if it was COVID or not, or what skills coming from the past. It doesn't really matter. These are always kind of a pain in the butt to be good at. So if you get stuck on these, don't feel bad. Ask a lot of questions, but we need to practice those a lot and make sure we're okay. Last mini thing today, we're pretty much done. That was the highlight of it. Is there is a formula to change the base, if you would like to any other base you want, which is really nice. In practice, you'll never see a science textbook or anything in the real world with a log base 3 or a log base 11. It's not going to happen. Everything you ever see the rest of your life will probably be what we're talking about today, a common log, log base 10, or a log base E, which we'll talk about on Friday, called a natural log. So if some freak in the world did give you a base that was strange, like a log base 4 or a log base like 29 or something like that, you might want to change it over to the bases that everybody does use all the time. So there's this change of base formula right here. It's a minor thing. You're probably not going to need it a lot, but there'll probably be some problems on there that say, hey, can you go change the base to something else? And what this equation stands for is on the right, C, there's this new letter C out of somewhere. C is whatever base you want it to be. You can change it to a base of C On the right, everything has a base of c now, whatever base you happen to choose. Although the way I remember this formula specifically is that, see how the b is kind of lower right here? The base is lower, right? And this is kind of higher. So I remember that the higher one goes on the top and the lower one goes on the bottom. So it's log of the top thing, log of the bottom thing on the bottom, and then you can change to whatever freaking base you want. It's very simple. You just kind of plug in that equation. It's an easy assignment. So let's do this thing. Evaluate log base 8 of 30, but you're not allowed to go use the math log base thing. You can't do that. So here we go. Log base 8 of 30, very easy. You're only allowed to use base 10. That's the rule today. From now on, this entire lesson, if you're not using just that log button, then you're not doing it right. This is base 8 though, isn't it? So that's exactly why we're going to change the base to base 10. So according to my formula right here, let's mash things up. The b is 8, correct? And the x is 30. So we're going to change it over to base whatever we want. We could change it to log base 7, but we don't have a log base 7 button on the front, do we? We could change it to log base 1,000 if we wanted to, but we don't have a log base 1,000 button. We want to turn it to log base 10. So I'm going to call log base 10 of 30. Do I need to write the 10, by the way? No, I don't need to, do I? No, I'm just emphasizing that I'm changing it to base 10. You could just write log if you wanted to. On the bottom, what am I going to write? Log base 10 of 8. Yeah, that's it. And like you said, yeah, you don't really need the 10s. If you want to write the 10s, go ahead. It doesn't hurt anything to write that the base is 10, but you don't need to. And then you can just type in your calculator, right? Got those buttons right on the front. You just type in log of 30, divide by log of 8. See what you get. I don't know what it is. Probably 1 point some weird crap. 1.6. So I have no idea. I can't do logs in my head. No, we can't. So yeah, we got the same thing. 1.6 something. Okay, that's it. That's all the change of base is about today. So just if they give you a base other than 10 today, since everything is about base 10, convert it to base 10. Okay. So the big theme is everything today should be solved only by hitting that log button, right? In fact, you don't even need that. Usually, most of you just do it on your paper, and you don't even get a decimal. But if they ask you for a decimal, you do that. Do not go to the math log base anymore. From now on, it's kind of forbidden, okay? We're just going to use log base 10. And then on Friday, we're going to do the exact same lesson again, basically. Only we're going to use log base E. But it'll be the exact same mechanics. So we're good. Any questions over anything today? All right, guys. Well, that kind of summarizes it then. So you got 8.2 due. Don't forget to get that taken care of. And then you got 8.3, the new stuff, due on Friday. We'll work on that tomorrow. Ask questions if you need, because some of those equations are kind of tricky.